All right, are we live? Looks like it. All right. Hi, welcome to Mr. Linford's class. Today in our live stream, I wanted to go over a couple of problems from yesterday's section 11.2. I'm just going to go over the two exit ticket problems for the quadratic formula, and then take some time today to go through some problems from the practice test. I've been asked to review problem 13, one of the rational equations. I might go over a couple more of those and some radical equations, but if you have any in particular that you'd like me to go over or any questions that you have, please let me know in the live chat that we have going on to the side. Let me know if there's any questions, comments, or if you'd like me to slow down or re-explain anything, just type a message over in the live chat. All right, let's get started with yesterday's topic. That was section 11.2, and this is problem 1 from the exit ticket. Now, section 11.2 was, again, solving quadratic equations, but this time it was solving quadratic equations using the quadratic formula. Now, the quadratic formula, I'm going to write it down so we remind ourselves. X is equal to negative b plus or minus the square root. And in the square root, we have b squared minus 4ac all over 2a. Make sure you have this memorized down. If you're still working on it, it's really important that you have this memorized because you're going to be using it quite a lot in your further study of algebra. Now let's go ahead and identify what we have here. First, I guess it's important to say, make sure that it's in the proper format. And yes, we have the quadratic in the proper format. A here is a 4, B here is 7, and C is negative 15. So I'm going to plug those in. I have a negative 7 plus or minus the square root of 7 squared minus 4 times 4 times negative 15 all over 2 times 4. Now, keep in mind here, it's important that we include signs with what we're working with. So you'll notice that I have a negative 15 for C. Let's go ahead and start simplifying. I get negative 7 plus or minus the square root of 49. And then, oh gosh, what's 4 times negative 15? Well, let me grab my calculator here. And again, we're going to make sure we're careful with our signs because we have double negatives. So I'm still seeing people sometimes forget about that. So make sure you're careful with it. So we get a positive 240. And that's all over 8. If we keep going, we get negative 7. Let me write that a little nicer. Negative 7 plus or minus the square root. 240 plus 49 is the square root of 289. That's going to be over 8. Let's see if I can simplify this any further. Hey, it works out. The square root of 289 turns out to be 17. And that's over 8. So it looks like we're going to get a whole number in the numerator. So let's actually figure out what those numbers are. Negative 7 plus 17 divided by 8. Well, that's just going to be a fraction. So I get 5 fourths. 5 fourths. And negative 7 minus 17 divided by 8 is negative 3. So these are the two possible solutions that we would have for the quadratic. Again, we got both of them from the quadratic formula. Notice the quadratic formula does have a plus or minus because they're the two possible values for the square root. So make sure you check both of them, okay? I'm going to do one more problem, and then we're going to get into the practice test. Notice here, again, we have a quadratic, and it's set up in the right format. We call that format standard form, by the way. Let's identify the A, the B, and the C. A is a 1, B is a negative 3, and C is 3. So let's go ahead and plug it into our formula. We get X is equal to negative B. So I have negative 3 plus and minus the square root of B squared, so negative 3 squared, minus 4 times A times C all over 2 times A. All right, let's start simplifying. Negative of negative 3 is positive 3, plus or minus the square root of, okay, negative 3 times negative 3 is 9. And then 4 times 1 is 4, times 3 is 12, so 9 minus 12, and that's all over at 2. If I keep simplifying, we get 3 plus or minus the square root of 9 minus 12 is negative 3, all over 2. And we want to simplify the square root of negative 3. So that's going to be 3 plus or minus I root 3 over 2. Because that negative comes on the outside, it becomes an I. So we're dealing with complex numbers, and we can leave our answer like this. Can't really simplify it anymore. But that's going to be our solution for the second exit ticket problem. Hopefully these are making sense to you. Again, we're recalling some of our work back from when we were dealing with square roots. So making sure that you're comfortable with square roots, things like that. And really making sure that you're able to simplify things down, I guess, is the main thing. The biggest errors I see people make with the quadratic formula, besides not remembering what the formula is, really are the signs. Like, for example, sometimes people wouldn't pick negative 3 for b, they would just pick 3. Or sometimes when they have the double negatives, they forget about 1. So just being careful with that and keeping your work nice and organized would be key. Now let's get into the practice test. I was asked to go over problem 13. This is one of our rational equations, ones that deal with fractions. Now, my preferred method for solving rationals is to clear the fraction. So that's what I'm going to do for this problem. I'm going to attempt to clear the fraction. By doing that, I need to find what's the common denominator. What's the denominator that, if I wanted to add them all together, they would all have to have? Well, part of the denominators are, they're not really factored down, right? I have larger polynomials here. So it would be nice for me to see everything factored down. Now you'll notice this polynomial is factored, so I don't need to do anything. And then this is just over a 1, so I don't need to do anything there. This is the thing that I want to factor down. So let's go ahead and do that. I get x over x plus 6 is equal to, now hopefully you notice that this is the difference of squareds, x plus 6, x minus 6. So that's what I'm going to represent that denominator as. And then again, I have 4 over 1. So what would my common denominator be? Well, the common denominator is the combination of all of the factors that are in all of the denominators. By that I mean, take the factors from all of the denominators and don't repeat any of them. So we want to see, gosh, I'm trying to think how I want to phrase that, but really just kind of say to yourself, what do all of the denominators have, and let's link them together. So they have an x plus 6 and an x minus 6. So the common denominator is going to be x plus 6 times x minus 6. And then you could say times 1, but that doesn't really do anything. So here is the value that we're going to multiply everything to. So let me try to write it rather small here, but I'm going to show how I'm going to take this common denominator, x plus 6, x minus 6, and I'm going to multiply it to each one of these terms. That is essentially the idea here of clearing the fraction. You multiply it to each of the terms. I'm going to try to do this color-coded just to make it a little nicer. I like color coding these problems especially and showing all of my work because it's very easy, as you'll see, that we can make a small error somewhere. So by writing everything out, it makes my work a little bit easier to deal with. All right, let's see if I can fit this here. X plus 6, x minus 6 times 4. All right, good enough. Let's go ahead now that I'm multiplying each of these terms. each of these three individual terms by the common denominator. Let's go ahead and let's see what cancels out. Because again, the purpose of when you multiply to clear the fraction, your goal is to cancel out all of the denominators. You multiply by something large enough that all of the denominators essentially divide out from it. So in the first problem, you'll notice that I have an x plus 6 on the bottom and the top. So if you have an x plus 6 in the numerator and 1 in the denominator, they just cancel out. They divide to a 1. And then in the next one, I have an x plus 6 and x plus 6 on the top and bottom, and an x minus 6 on the top and the bottom. So the x plus 6's are just going to cancel out. They're going to divide to be a 1. Same with the x minus 6. Now nothing is going to cancel out in the last one, and that's okay. Let's see what we're left with. We have x times x minus 6, and I'll wait to multiply until later. Then we have what's left here, 72, and we're left with a 4 times x plus 6 times x minus 6. So we can see what we're left with, what didn't cancel out. We're going to have to, if we're going to try to solve this, we're going to have to go ahead and obviously distribute things through and try to combine some like terms. So let's see what we get. An x squared, when I distribute the x through, I get an x squared plus, an x squared minus 6x equaling 72 plus 4 times, well, when I multiply these binomials together, it was an x squared minus 36. So let's see what else we have here. X squared minus 6x, and then we have a 72 plus a 4x squared minus 4 times 36 is 144. So we can combine some like terms here. But first thing that we should notice is that we have x squareds in our answer. And when we have x squareds in our answer, things raised to this, or variables raised to the second power, we should be saying to ourselves, how can we go and solve this? Well, we should be saying it's a quadratic, so we need to solve this using any of the methods that we can for solving quadratics. Because, I mean, what other way is there, right? It's not like you can keep isolating the x value. What we have to do is either, 1, hope that the zero product property works, or we could, 2, use the completing the square method, or, now that we know it, we could use the quadratic formula. Well, let's see what we get when I combine everything. So I should move the x squared over, and let me move the 6x over too. Remember, when you're solving quadratics, you want them to be set equal to 0. You want all of the quadratic on one side. So I get a 3x squared plus 6x minus 72. Well, first thing I'm noticing is that polynomial can be factored down, can it? The 3x squared plus 6x minus 72. If I'm looking at that, I'm thinking, there's a GCF of 3 in there. So I'd probably factor that down. Let me try to get some more room here. Let me go to the next page. We had the quadratic 0 is equal to 3x squared plus 6x minus 72. Okay. Let's factor out the 3 from that. Because if I can deal with smaller numbers, that's a lot nicer. And, oh gosh, 3 out of 72 is 24. So really the thing that I have to break down is x squared plus 2x minus 24. Let's see. Maybe we'll try the zero product property. Let's see if that works. And let's see what multiplies to give us negative 24 but adds to give us 2. I'm thinking 6 and negative 4. So x plus 6, x minus 4. These factors should work. And again, if you can break it down, you can set each of these factors equal to 0. So x plus 6 equals 0, and x minus 4 equals 0. So what could the x's be? Well, x could be a negative 6, and x could be 4. When solving the quadratic, we get these two solutions. Now, let's take a look back at what what our work was, we attempted to solve a rational. They got to get better names for these. We attempted to solve a rational equation. And by doing that, we decided to clear the fraction. So we went through and we cleared the fractions. So we no longer had denominators to work with. We had everything up in the numerator, so we could combine like terms. And we noticed that when we cleared the fraction, the resulting answer that we had was a quadratic. So we manipulated all of it, got everything onto one side to get this quadratic to solve. So essentially, when you're solving rationals and you clear the fraction, you're either going to get a linear equation, something easily that you can solve for. I think we had some examples of that. I'm looking at problem 14. When you clear the fractions, you actually get a linear equation where you can just solve for x. But in this problem, we got a quadratic. That means we have to use one of our techniques for solving quadratic equations. And we did. We used the zero product property, and it worked. We could have used the quadratic formula. We could have completed the square, but I figured we'd just practice the zero product property. Now, one thing that we have to keep in mind, we have to check our work, because these answers might be they are solutions to this quadratic equation, but are they solutions to the rational? That's the thing. Again, when we have a rational equation or a rational function, remember, it has a restricted domain. There are things we can't plug into it. By converting it to a quadratic, something that has an infinite domain that we can plug values in for, all the different values in for, we run the possibility of maybe we accidentally picked something that was in the domain of the quadratic that wasn't in the domain of the rational. So we're going to have to go and test these answers. So let's test, I guess we'll start with -6. So we're going to check our work here. And, well, if I'm looking at this problem, I'm immediately seeing -6 is not going to work for x. Watch. -6 all over -6 plus 6 equaling -6 squared minus 36, and I got a 72 over that, and then plus 4. Right away, you should be saying, this isn't going to work. Look right here, -6 plus 6, that's a 0. This is going to be a 36, and when I subtract 36 from that, it's also going to be a 0. So this setup isn't going to work. X equaling -6 is going to be extraneous. Okay? It's not going to work because it's going to give us zeros in the denominator, and we can't have that. So our next hope is maybe 4 will work. So let's plug 4 in. We get a 4. If my stylus would work. We get a 4 over 4 plus 6 equaling 72 over 4 squared minus 36. Let me write that a little nicer, 36. And then we're going to add 4 to that. All right. Make sure you're using your calculators to double check your work. A lot of times people tend to make very small errors here, and then they might label something as either being a solution or an extraneous solution when it's one or the other. So let's see, we get a 4 over 10 here, and we have a 72 over, well, 4 squared is 16, minus 36 is 20. Well, let's just go ahead and write that down. Or I should say it's a negative 20, so I have negative 72 over 20 plus 4 here. We could go ahead and simplify things, but I'm just going to type it in my calculator. I'm going to cheat. Negative 72 divided by 20, and then I'm going to add 4 to that and use the fraction feature. So I get 2/5. So I have 2/5 on the right-hand side, and on the left-hand side, 4 over 10, that also simplifies to 2/5. So it works. 4, in fact, is a solution to this rational equation. Okay? Remember, 4 and -6 were solutions to the quadratic, but we're checking to see if they're solutions to the rational. So that works, okay? On the test, which opens tomorrow, you do not have to list both solutions. Just write the one that is a solution. If there is no solution, because that can sometimes happen, right? We'll see some examples even on this practice test where you solve the quadratic and you get two answers, and it turns out none of them work, okay? You would then write no solution on your test. You don't have to worry about extraneous or writing something and labeling it extraneous, okay? So on the test, I would just expect you to say 4 is your answer. If you wanted to, you could write 4, and then you could write -6 and write extraneous after it, but you would have to put extraneous. If you didn't put extraneous, then I would have to mark it wrong. So please make sure that you either just put the answer, or if you put both of them, you label whatever's extraneous. And if there's no solution, you can actually type no solution, okay? So I hope that problem makes sense. I had a student ask about that one. If you have any questions about it or any of these other problems, please let me know. I would think we'd go over one more of these. I'd like to take a look at... I'm looking. Maybe we can take a look at problem 14. Yeah, we'll give problem 14 a try. Again, if there's any problems that you want me to go over, just let me know in the live chat. But problem 14 is 5 over x plus 3 minus 2 equaling 7 over x plus 3. So this is a nice one. We can easily see what the common denominator is. It's just x plus 3. Let me write that a little nicer here. Because that's really the only denominator. And again, this 2 is like over a 1. So we're going to multiply both sides of the equation by x plus 3. I'm going to try to write this color coordinated. And let's see here. 2 times x plus 3. And this is going to equal 7 over x plus 3 times x plus 3. Okay, let's go ahead and now let's see what cancels out, because that's really the purpose of clearing the fractions. So we have an x plus 3 on the top and the bottom. Those divide out. And we have an x plus 3 on the top and bottom, so those divide out as well. What we are left with is... looks like just a 5 in the first term. The second term, we have, well, let's distribute the -2 through. -2x minus 6. And then in the last term is just a 7. So let's go ahead and combine some like terms. We got a -2x. 5 and -6 is -1. That's equal to 7. We can add 1 to both sides. -2x is equal to 8. And x is equal to -4. You can see in this problem, our resulting answer was actually a linear equation. It was not a quadratic. So this one is one that we can just solve by doing just a simple linear process. Again, though, we're going to have to check our work. We have to see, is this in fact a solution not just for this linear equation, but is it a solution for the rational? Let's see here. Let me make sure I have enough space. 5 over -4 plus 3 minus 2 should be equal to 7 over -4 plus 3. Well, -4 plus 3 is -1, so that's just -5 minus 2 equals, again, -4 plus 3 is -1. So that's just a -7. So -5 and -2 is -7, and that sure does equal -7. So it works. We have -4 is in fact a solution for the rational equation. So we found a true solution for it, so we're good. We're going to have to keep this going when we also solve radical equations. I'm going to flip the page here on the practice test, and I'd like to take a look at a couple of these radicals. First up, let's take a look at, I'm looking at problem 19. That looks like a good one. Problem 19 here says the square root of 3x minus 5 minus the square root of 3k equals 1. So the square root of 3k minus 5 minus the square root of 3k equals, it's a negative 1. Okay, let's go ahead and solve this. Remember my technique here of saying let's isolate one of the radicals. Okay, the only way to get rid of the radicals is by squaring both sides. It's easier, though, if you get the radicals on separate sides. So I'm going to say let's keep the more complicated radicand, the 3k minus 5 on one side, and then I'll add the root 3k to the other side. So let's go ahead and square both sides here. By doing this, I can easily get one of them to simplify. So I can easily get the square root of 3k minus 5 to just be 3k minus 5. The root and the exponent just cancel out. The next one, I'm going to have to FOIL this or box method it. So I'm going to do that to the side here. 3k and negative 1. I got to multiply that by root 3k and a negative 1. Root 3k times root 3k is 3k. Negative 1 times negative 1 is positive 1. This is just the negative root 3k and negative root 3k. So what do we have here? We got a 3k plus a 1. And then I got two negative root 3k's, so that's minus 2 root 3k. Okay, we did this process so that way we get one of the radicals. We still have another radical to deal with, but that's okay. How do we get rid of it? We're just going to have to square both sides again. First, though, let's go ahead and combine some like terms. I could subtract 3k from both sides, and those would both just cancel out. And I could subtract 1 from both sides, so I have a negative 6 is equal to negative 2 root 3k. You know, let's go ahead and divide both sides by negative 2. Why not? We'll get 3 is equal to root 3k. And then we could square both sides. We would get 9 is equal to 3k. Let me clear my space here. And we get k is equal to 3. That should be our final answer. K is equal to 3. Of course, we have to go and check this. Let's see here. We get the square root of 3 times 3 minus 5. And we're going to subtract from that the square root of 3 times 3. And we want to say that's equal to negative 1. So 3 times 3 is 9 minus 5. Minus the square root of 3 times 3 is the square root of 9. 9 minus 5 is just a 4. And the square root of 4 is 2. Square root of 9 is 3. And yeah, 2 minus 3 is negative 1. So this works out. We're good to go. This is, in fact, a true solution to the original radical equation. Okay, it's not extraneous. You will notice, though, I'm looking at other problems, there are a few extraneous solutions. All right, some of which we've done in the past, so there's nothing new about that. Really, I want you to make sure you have this process down. Make sure you're comfortable with this idea of when you're working with multiple radicals, get them on separate sides. And really, just keep squaring both sides. That's the only way you're going to get rid of radicals. You just keep squaring both sides. Use the box method. Make sure you get some scrap paper. Give yourself some space. Keep your work as organized as you can. Okay? Those are my, really best advice that I can provide. Just keeping your work organized. Because the rest of the work is pretty straightforward, I would say. It's stuff that we've done in the past. We're just working with polynomials now. But you have to make sure it keeps organized and you're making sure you're detailed in your responses. I don't really see any questions over here in the live chat, and I don't really have anything else that people wanted to go over. So if there are no other questions or no other topics people want me to review, I think we'll end a little early. Feel free to contact me if you do have any questions. I'm going to be answering email. Our test goes live tomorrow in Edge Elastic, so feel free to contact me at klinford, that's KLINFORD, at wccnet.edu. And until next time, take care.